Can you guys hear me? Okay, okay. So, great. So, did any one of you get a chance to look at the lecture? Otherwise, that is the same lecture that go through at a high pace, right now. And this lecture will also be a part of your midterm. I could not actually upload the lecture yesterday. I'll finish it off by tonight, I'm hoping, and there will be like one more lecture. So these two lectures together, and in total, the four lectures that will be uploaded plus whatever we did before um I got unwell. That will be the part of your syllabus for midsem. And as I said, on 19th, I'll have an extra class for both batches. And if you have any doubts till then, you can ask me on 19th, right? I know it's going to be a bit difficult for you guys to prepare probably the last two lectures because you won't get too much time. But it'll be about C++, so I think it will be interesting. So maybe it'll in fact, whatever concepts we are going to study in this lecture, basically the next two lectures are about those concepts in C++. So conceptually, it will be the same. It will be a little bit on the side of syntax. Okay, so let's start, guys. Okay. Uh, and as always, once I go into this mode, uh, the problem is if I lose my internet connection, there is really no way for me to know it. So okay, anyhow, I mean, if my voice starts breaking, just someone should unmute and tell me, and otherwise I'll just keep on going. Okay. Laser. So this lecture is about inheritance and data hiding. Okay. So there are certain concepts related to object oriented programming. Inheritance is probably the most important concept. There are some other concepts like abstractions and the concept of polymorphism. But I guess inheritance in some ways is probably the most important concept. related to object-oriented programming. So a good way to look at it is, let us say if you want to cook pizza at home, right? We tried it during the lockdown period. Uh, so we came to know that you get these pizza bases. Okay, so it looks like a, a cream colored base. Okay, just the base, and it's basically made up of dough, right? I mean, wheat flour, and what you can do is you can have that pizza base, and then you can use that pizza base at your home. You can actually put some cheese over it. There is actually a pizza sauce that comes up in the market. So the idea is you apply the sauce, you grate some cheese, and this is basically the basic pizza that we all know. And over that you can put whatever toppings you would like, right? So different people might like different types of toppings, and once you do that, you can cook it in an oven, or you can even cook it on on those flat bottom utensils. We call it tawa in Hindi. I'm not sure what exactly is it called in other languages, and but yeah, you can cook it like this. So the idea here is, let us say there are two different types of pizzas that you are trying to cook, right? You can see that in this whole process, up until the last point where you actually put the toppings, everything else was basically common, right? You have to buy the pizza base from the market, you put the pizza sauce over it, you grate some cheese over it, and it's just the last step. Okay, at the last step you can either put, let us say, onions and tomatoes, or you can put paneer and capsicum, whatever it is, and then you have two different pizzas. Okay, and this whole concept, right, where you say, there's going to be something common up to some particular step. This is not just there in cooking, you'll also find it in computer science. So let us just have a look at this picture. So essentially these three layers are exactly the same in these two pizzas. It's just that the last layer changes, right? So this whole concept, okay, is in some ways what we are trying to do is we are trying to build something, right? Here the something is pizza. Okay, onion on and tomato pizza, or paneer and capsicum pizza. So whatever we are trying to build, if we look at it hierarchically, right, layer by layer or step by step, it is quite possible that you will find things which are common with some other product, some similar product, right? So the inheritance is basically the idea of building stuff hierarchically, right? The overall idea is that you start by identifying some common elements. Okay, and this is like the base layers, and then you keep on diversifying. Okay, at each layer maybe you would like to bifurcate or trifurcate, or basically you can have n number of ways in which you can differentiate from a particular level. So this is the whole concept of inheritance, that instead of trying to look at a product as one monolith as in it's like one block, you start looking at it from the perspective of layers, right? You say, okay, this is common at this layer, this is common at this layer, so on and so forth. So what really happens, at each layer you basically extend the previous layer, and you build a new layer, and this new layer is kind of a it's kind of a specialization of the old layer. So this is the major contribution, this is the major aspect of object oriented programming that you need to learn. This is, as I said, right, this is basically a kind of design aspect. You have to inculcate this in your thinking, that whenever you are given something to build, don't just look at it from the perspective of building one system or one module or one class, right? You should try to see if it is possible for you to somehow get things which are from layers which are already available. Or if you are going to build a system that is going to be very complex, which is going to have a lot of entities, then it is always a good idea to think about it in such a way that if there is something common between those entities, you start at an abstract level, at an abstract step, and then you keep on diversifying from that step. This is the overall idea, right? So basically, in this process we add more attributes to entities in a hierarchical fashion. So we start with very basic attributes which are common, let us say, across a lot of entities, and then at each level you keep on adding more attributes, right? So in the pizza example, basically, I say that we at this particular level, after grating cheese on the pizza, I can now have n number of different ways, right? So one way is that you put onions and tomatoes, the other way is paneer and capsicum. There can be many more ways, right? So that is the idea, that you started with a basic entity, because each pizza will have a pizza base. All pizzas have the pizza sauce. I think all the pizzas also have this cheese. So up to this point you realize that this is common, right? Anyone who's supposed to build a pizza will be required to do these things. And at this particular step, from here onwards you can diversify, right? So this phenomenon is known as inheritance. And in this whole class hierarchy, the class which is the generic type is known as the base class, and the classes which inherit it or extend it, right, are known as derived classes. Okay, so this is just a simple hierarchy. So I can actually extend this hierarchy to one level higher as well. So this part we have discussed, that a pizza could either be onion and tomato pizza, or it could be paneer and capsicum pizza. I can actually extend it at one higher level. I can basically say there are things like wheat based dishes. Now it could be a pizza or it could be noodles, right? Noodles also, that it's a very common snack that people have. And then I say that these instant noodles, by the way, these instant noodles are, I think, Maggie and what Sunfeast and all those things. So these are instant noodles. So they are just like one type of noodle. So this is a kind of a hierarchy, that the properties at lower level, they actually inherit the properties at the higher level, and then you add something more at the lower level. This is the overall idea of inheritance. Okay. Um, yeah, so basically we can see that we can view the derived classes as specializations of the base classes. Any questions till now? So this part is clear. The overall idea of inheritance is clear, right? That the and it's not just an idea. You have to inculcate this in your thinking, that whenever you are going to build a system, instead of looking at each entity independently, you should now start looking at them from the perspective of what exactly is common in, let us say, these two or these three or these four, right? I mean, you should start looking at your world. Everything around you probably has this property. So inheritance is not something that is just there in computer science. It's a generic concept. You can look around, in your environment, and you can say, okay, this is an example of inheritance. You can say that automobile is the base class, and four wheelers and two wheelers are both derived classes of automobile, right? They are both automobiles, it's just that one has four wheels, the other one has two wheels. Similarly, you can say, uh, you know uh, plants are, let us say, the base classes. Then you have shrub as a derived class, right? Things like this. So basically from here onwards, your thinking towards your environment should change, right? You should start looking at your environment from the perspective of inheritance, that this is a generic version of this, and this is a specialized version of this. Okay, the moment you actually inculcate this in your thinking, you have essentially grasped the concept of object oriented programming as well as inheritance. So is any questions? Okay. So when we actually do this, right? Whenever I say that let us create a class, and later onward I'll just extend this class and I'll create another class. Okay. By the way, coming back to computer science, we do all these things using classes, right? I mean, pizza and everything is the real world example. When we come back to computer science, we are talking about classes. That there is one class which is kind of a generalized version, a generic version of another class, and the generalized versions the properties are inherited by the derived classes. So whenever we do this, right, whenever we create a class, and we have actually, in fact, the lecture that I'm probably going to upload today. Again, I said it yesterday as well that I'll upload it today, but there's a good chance that I'll do it today. So whenever you create a class, you have to figure out the visibility of its elements to the outside world, right? So I'll give you a simple example that when you go to market and buy the pizza base, you really don't need to know the recipe of how the base was created, right? I mean, the makers of the pizza base, they do not put that in the packet, right? At least I haven't read that they put the recipe of how the pizza base was made in the packaging, right? Because they don't need to. Okay, you are not supposed to know how the pizza base was built. You're just supposed to use it, right? So many a times this will be something that you'll have to think, that whenever you are creating a class, there might be certain attributes, there might be certain behaviors which are important for the class for functioning, but for the rest of the for any code that is outside this class, it doesn't matter, right? I mean, you really don't need to know the details of how this class is achieving something, right? So this is the idea, that whenever you are going to create a class, you will have to think about the visibility of its members. Now the problem here is that one way to do it is that you basically restrict everything to have no visibility outside. So you basically say, not only am I not going to reveal the recipe of my pizza base, I will also not reveal the contents. So you know that it's probably legally expected from people who produce food to write the ingredients or contents of their food product on the label, right? It's important because people can see what are the ingredients, is there something to which I am allergic to, or something that I do not eat, things like this. So if you actually start making pizza bases where you don't even tell what are the ingredients, okay, then it might be difficult for people to use it, because I really don't know, whether I don't have egg, for example. So if your pizza base has egg, and you are not going to tell me, I'll probably say, okay, I'll buy it from someone else. So this is the issue, that if you are creating classes which are too restrictive, that nothing really is visible to the outside world, it might actually reduce its usability. Okay, it might not be that usable. On the other hand, if it is too permissive, right, you basically reveal everything, then there is basically a kind of a risk associated with it, right? For instance, if your pizza base is so customizable that you can actually bring it home and then change it into noodles, okay, then it's really wrong to call it a pizza base, right? It can be used to create noodles also. So maybe I'll just want to have the pizza base built in such a way that it cannot be used to create noodles, but at the same time, I'll tell you what are the ingredients. I know these are all lame examples, but I'm just trying to correlate it with the real world, that whenever you build something, um, you have this decision or at your hand, that exactly how much amount of details are you going to expose about it. And this is a very fine level. Okay? For different products, for different classes, this level will be different. So as a person who's going to analyze the system, and this is why you can understand that this subject is more towards system building. Okay, it's not really that important from the perspective of competitive programming. This is more important from the perspective of um, doing actual engineering, right? You are supposed to build something, and you need to know exactly what amount of information should be conveyed, for example, to your user. So this is the idea, that in each class you'll have to basically hide or expose certain features, certain members. There is a principle called the open closed principle. So it says that software entities, which includes classes, modules, functions, etc., should be open for extension but closed for modification. So this is a very old principle, open closed principle. And the overall idea of modification versus extension might be slightly confusing for you right now, right? So again, this is a lame example, but I'm still continuing with it because it is a non-computer science example. So I say that assuming that the pizza base that you bought, I can actually convert it into noodles, then this is an example of modification, right? The the core behavior of your pizza base can be easily changed, right? It can become something else. So then this is basically modification. Okay, the core behavior of your product, the core behavior of your class. If your derived classes can basically simply modify it, it's not even for derived classes. If you can if you can simply overrun a class, right? Because everything is open for modification, then this is probably not good. The idea of extension is that the property of the class of that entity still remains, but you use that property to build something more complex, right? So this is the idea of extension, that you take the pizza base, you apply the sauce, you apply the you grate cheese. The pizza base is still pizza base, it hasn't become noodles, for example, right? It is still a pizza base, and then you build a pizza over it. So this is the idea that in most cases you should prefer to build a system in such a way that it is open for extension, but it is closed for modification. Okay, so this is, I know that it might be a bit confusing right now, but as you keep on building more systems, you'll get to know what modification is and what extension is and how modification differs from extension. But as of now, just understand that whenever you create any new entity, the idea is you should try to stop its modification and encourage its extension. Any questions still here? Okay. Yeah, I don't think it's really that interesting. Maybe when you'll start doing all this stuff in C++, it might become a little more interesting, right? This is just theoretical aspects, so sometimes it becomes difficult to imagine these theoretical things. But it is necessary to learn the theory first, so that when you do practicals, you understand. So anyhow, let us take an example of inheritance. Okay, so I'm not sure how many of you follow cricket, but I'll just give you a very simple introduction. So cricket in international at international level is played in three formats. Okay, test matches, ODIs, and T20s. These test matches actually last for a much longer amount of time, 5 days to be honest, up to 5 days. ODIs, they are known as 1 day international, so they last for, let us say, 1 day from morning to evening, around I think 8 hours of time or something like that. And the T20s are the shortest form of the game, where a match typically lasts for around 4.5 hours or so. Okay. And by the way, where you I think at least all of you know that in cricket there is a concept of batting and bowling. So in test matches, whenever one team starts batting, there's essentially no limit to the number of balls that they can play. Okay, whereas in ODIs and T20, we call them limited over versions of the cricket as well, because you don't get unlimited number of deliveries to face. There is always a limit to it. So let's just say we want to create a new format. We want to represent we want to create a class that represents a new format called T10. I don't think it's a new format. I guess it is being played somewhere. I think I read it in the news that they do play T10 somewhere. So it's not really new. But let us say you want to represent this new format. It's called T10, right? Which means that there will be 10 overs for each side. Don't worry about these details basically. Okay. So now the one way to look at this is, as I said, right, the monolithic approach, where you say, okay, everything that I want to represent, everything that I want to store, it should be a part of this class. So I write things like this. I need to store the result of the toss, the names of the teams, right? The playing 11. The scorecard for the first innings, the card for the second innings. We need to store the name of the team who won the match, so on and so forth. Okay, so one way to look at it is like this: that if I create a class, these are some of the members of this class. Again, as of now, we are just treating a class pretty much like a structure, right? We have not talked about any methods, any functions, right? These are just attributes. So this is as good as a structure. So I say that one way to do it is like this: that you basically create a class and you add these members there. And yeah, by the way, team and innings, they are themselves classes, and you are basically creating objects of these classes within your T10 cricket match class. So this is another way to build stuff hierarchically. One way is using inheritance, where you basically extend a class and create a new class. The other one is known as aggregation. So I think we had a look at aggregation in the lectures on modeling. The aggregation approach basically says that I declare a variable of that particular type within the new type. And this is what is happening here, that these team and innings, these are variables of two other classes, team and innings. So now assume that you're planning to represent this for some purpose, and whatever system you are going to build, it also has these classes, or you are supposed to create classes for test, ODIs and T20s as well. So now this is where things become a little interesting, that because all these are essentially a form of cricket, there are a lot of things which are common to these three formats, right? In fact, for those who understand cricket, they'll know that other than the innings based scorecards, the scorecards will have only 10 overs, for example. In a T10 match, it will have only 20 overs. For T20, it will only have 50 overs for ODI, and any number of overs in test. So other than probably the scorecards, probably everything else is exactly the same in tests, ODIs and T20s. So one way to create this same this same entity is by first creating an entity called cricket match, putting the common terms here, and then you inherit it and call it T10 cricket match, and you add the new property here. So this is a very simple example of inheritance, that you can either create it like this or like this. So what is the advantage of this over this? The advantage here is, if I am also required to create a class to represent T20 cricket match or ODI cricket match or test cricket match, I can simply do more inheritance stuff here and create new classes like this. In this approach, I will have to simply replicate all these fields in T20 and ODI and test and all those things. So this is the advantage of inheritance, that you create one class and then you keep on inheriting it and adding more properties to it. So the properties of the base class are already a part of your derived class. Okay, any questions still here? Okay, yeah, I know it's really boring, but we have to, go through some of the theory in order to, do some stuff. Okay, so whatever we saw till now, as I said, right, these classes were as good as structures, right? I mean, there were no methods there. They were just fields. In general, your classes will also have methods. Okay, methods as in functions are there. So, for example, let us say you might have a function which represents the toss event in the match, right? So I'm going to call it flip the coin. That when you flip the coin, there will be an output. Okay, it could either be one team winning the toss or the other team winning the toss. The caller or the tosser. Either one of these two captains will win the toss, and so essentially there will be a change of state, right? In the beginning, when your object of this particular class is created, let us say the toss field could be set to null, and whenever you call the flip the coin method, um, the value is set to the team which won the toss. Okay, the value of the field toss is set to the team which won the toss. Now another example could be, let us say, a method called add scores. Okay, so add scores are essentially a method where you keep on adding um, a scorecard to this match, right? So you remember that these scorecards will be different for different types of matches. So let us say I also want to have an add scores method where I add one scorecard, for a scorecard for one inning at a time, something like this. So again, if we go back to our inheritance-based approach versus the monolithic approach, this is how it will look like. So you can either create it like this: you add these two methods to the T10 cricket match class, or you do it something like this, that basically you add the method which is going to be common. The toss part is going to be common for all cricket matches, so you can add this in the cricket match class, and then only add the add scores part to the T10 cricket match. Okay, so the idea is that this inheritance, it is not just for fields, it could also be for methods. And in fact, the inheritance for methods is usually more interesting. Okay, because there is a concept of overriding. That is the concept that makes inheritance even more interesting. Okay, so similar to the fields, this visibility stuff, okay, what should be visible versus what should not be visible, has to be thought about for methods as well. um, so should all the methods of a base class be accessible to the derived class? Maybe not, if the method implements a core behavior of the class, right? So this is what I said, that you should not be able to change a pizza base into noodles. Okay, so if there is a behavior which is kind of the core behavior of the class, then it should not be visible, it should not be available to your derived classes. Otherwise you can let it go. So in general, we usually hide the fields of the base class from the derived classes and let the derived classes access the method. This is what we do in general. Okay, it is not really a rule, but whenever you create a class, the first thing you should think about is, by default, keep all your fields as private, something that is not accessible to the outside world. And by default, all your methods should be public. You can always think about it. In some cases you might want to make a field as non-private, and in some cases you might want to make a method as private. But that is the idea. And when I say private, as in private means that it is accessible only within the class and not to someone outside. So almost all oriented programming languages, at least all that I know, provide a way to decide this visibility, that a particular field or a particular method, is it visible to the outside world, is it visible to the derived classes, or is it going to be a private property of this particular class. So one more thing that we have to discuss, I think, is overriding. So whenever you are going to have a method being allowed to be accessed by your derived classes, there's one concept that makes inheritance far more effective, and this concept is known as overriding. We will study about overriding later, but I just wanted to give you a brief idea so that you can understand the concept of extension, right? You remember the modification versus extension part. So this extension thing can be very easily and very commonly observed with the help of seeing the behavior of inherited methods. Okay, so what exactly is overriding? It is something like this. There is a method that is there in a base class, and in the derived class you still want to have that method, but you want it to be changed, right? So for example, let us say your base class automobile has a method called fill the fuel, right? So it's a generic method. It says that go to the go to the filling station, and get the fuel filled. Let us say it prints something like this. Now when you actually extend it and make a, let us say, a Volvo bus out of it, right? I think Volvo buses run on diesel, right? So you would like to change this method slightly. You would say, when in the method, fill fuel, instead of just typing something like go to the filling station and get the fuel filled, I would like to print go to the filling station and get the diesel filled. That is the idea, right? So it's the same method, fill fuel, whatever it is. But in the derived class, you want to slightly change the behavior than what it was in the base class. So in such cases, we use a concept called overriding, and such methods, at least in C++ and Java, we call them, such methods have been overridden by the derived class. And in some cases, the base class simply leaves out a method. So it is possible that the automobile class does not print anything. It says, okay, let the derived classes decide how to fill the fuel. Okay, so in such cases, you declare the function in the base class, but you do not provide a definition for it. Okay, such functions are known as abstract functions, or in terms of C++ methodology, C++ terminology, it's also called as pure virtual functions. We'll get to virtual and pure virtual functions later, don't worry. So the idea that I'm trying to tell you is, in many cases, there is a method that is there in the base class, and you let the method remain there, okay, because that method might actually be representing a real world behavior, but you want that behavior to be changed for derived classes. If you want to do that, that is possible, and it is done using the concept of overriding. So this is like one way to understand what are abstract methods. So let's just say you also wanted to add get maximum overs in a particular innings for a particular cricket match. So I've just added like one more class here, limited overs cricket match. Now this can be inherited by all three, T20, T10, and ODI. And in this get max overs function, um, this is basically an abstract function. It doesn't provide a definition here. So and by the way, if a class is not providing definition for for even one member, then the class itself also becomes abstract. And when I say abstract, it means that you cannot create an object of this class, right? Why? Because if I create an object of this class and I want to call that particular function, because there is no definition, nothing can actually be executed. So such classes, the programming languages, they'll not allow you to create an object of such classes which has at least one abstract method. Okay, so we these classes are also known as abstract classes. These are classes which are used only for inheritance, and you cannot create an object of these classes. Okay, so this is just a simple example that this is an abstract class, this is an abstract method, and now all these different types of cricket matches, T10, T20, and ODI, they can give different definitions for get max overs. So this is an example of overriding, where the base classes method did not have any definition at all. So it's the responsibility of the derived classes to override the method and provide the definition. There is some homework. Have a look at it. Any queries, guys? I know I've been very fast, but you should, these are all stuff that I'm pretty sure no one wants to listen to in a live class. But these are important concepts. So either you listen to me or you watch some lectures on YouTube. But please learn these concepts. Okay, what is inheritance? How do you use inheritance while you are creating class hierarchy? You should know these things. It doesn't matter whether you learn from me or my lectures, but just read. You can also read the book, by the way, the the book for this particular course. You can read and try to understand that. Okay, any questions?
Sir, once again explain about abstract class.
Abstract classes, right? Okay, so let us say I want to create a class hierarchy, and in this class hierarchy, I want a particular behavior to be left as left to different derived classes. Okay, let me give you an example, another example. In fact, let us take the automobile example. Whenever I say, for my automobile, I am supposed to go to a filling station and get the fuel filled. Now this is actually too abstract, right? Too abstract, as in the I'm using the term abstract from English language, not a technical term. When I say this sentence is too abstract, it means that in real world this sentence does not actually have much of a meaning. Why? Because when I go to a filling station, I'll have to go to one booth, right? I'll have to go to CNG booth or petrol booth or diesel booth. I can't simply go to a filling station and say, please fill the fuel in my vehicle. They'll ask me, what is the fuel that you want in your vehicle? So that is the idea, that sometimes when you create these class hierarchies for inheritance, you might actually go to a level so high that a particular behavior, even though it's a real world behavior, um, its actual usefulness is gone. Why? Because you need a particular detail in order to tell me how, what exactly will be the behavior in the real world. But it might still make sense to use inheritance, because because of I don't have to write duplicate code, for example. So in such cases we take help of abstract functions and abstract classes. So abstract functions are functions for which I simply say, I do not have the details of how this function will work, but any derived class which is going to extend me, that class will give you the behavior for this particular method. So this is, in such a case, I call such a method as an abstract method or pure virtual method in terms of C++ terminology. And why do classes with abstract methods are also abstract? Because, as I said, right, if I create an automobile, let us say, in the real world, um, there are so many details that I'll have to come about. I'll have to know, right, what are the number of wheels in this automobile, what is the fuel on which it runs, so on and so forth. What is the capacity, how many people can sit in this? So I can't really create an automobile in the real world. In the real world, it will be either a car or a bus or a truck or something like this, right? So that is the same idea, that when you use this inheritance hierarchy, sometimes you might go so high that the actual uh, uh, the actual usefulness of that class has basically gone away, right? Its object should not really exist independently. Okay, the only way this class should be used is by inheritance and nothing else. So this is the idea of an abstract function, an abstract method, and by extension, the abstract classes are classes whose objects cannot be created. Okay, you cannot create an object of that class, but you can use that class to inherit, for inheritance. You inherit it into some other class. In that some other class, you provide definitions for the abstract methods, and now you are good to go. The objects of the derived class can be created. Okay, does that make sense? We'll have a look. We'll revisit abstract methods when we study overriding. But this is just to give you an idea of extension. The overriding is an example of extending the behavior instead of modifying it. Any questions? So yeah, I understand this was purely theoretical and it might have been really boring for you to go through this. But as I said, these are some some concepts that you should know, right? And maybe in the next lecture, when I start showing you some code in C++, it will be a little more fun. But as I said, code without theory and theory without code, they are both going to be difficult. So please bear with me. Understand that in this particular uh, course you'll have to learn some theoretical aspects as well. So this is basically the boring part. The interesting part will be when you apply it for your own analysis and you start building stuff. Okay, then all these concepts which are currently just a theoretical entity, then they'll become far more interesting for you. Okay, it's done by Yes, Divya, that is right. Okay. Data hiding, you do this by having different members of a class under different sections. You hide it from the rest of the world. In fact, there is one more. It's not just private and public. There is actually one more um, access specifier. There is one more access class. You'll get to know it when I show it to you in C++. But yeah, the overall idea is in data using data hiding. The idea is that whenever you create a class, you should hide all the details that are not necessary for the rest of the world to know. That is the idea. When you, let us say, when you buy a car, right? um, all the all the machinery, engine and everything, that is basically put inside the bonnet, right? I mean, you don't see it. Okay, because you don't need to see how the internal combustion engine works. Okay. All you need is you just need to drive the car. So the same thing is here. You might just need to use a class. You really don't need to know how exactly different fields of the class are going to interact with each other. Like, I think someone asked me yesterday that what are the fields of the string class, right? Of course, you can always go and check out what are the fields of string class, but usually you don't need to, right? I mean, if you just want to use the string class, you don't need to know what are the fields, right? All you need to know is how to create a string, how to manipulate a string, how to invoke certain methods like substring and all those things on the string object. You don't really need to know the fields of the class. So that is the idea of data hiding, that you hide the data that is not supposed to be uh, that is not supposed to be informative for the rest of the world. Okay, any more questions?
Sir, can you explain the modifying part with some examples of classes?
Yeah. So in the terms of class, um, let us say you have a field in your class. Okay. And in terms of automobile, let us say we have created a class called automobile, and it has a field called um, fuel type, let us say, right? And uh, while you created the class, you made fuel type as a public thing, right, instead of a private thing. So now it is quite possible for me, as a user, to do something like object dot field type equal to petrol. Then I wrote some more code, and then I changed object dot fuel type equal to diesel. Now, in the real world, it actually doesn't happen, right? I mean, the fuel type of an automobile is usually fixed, and I'm not talking about the cases when you apply an LPG kit or a CNG kit to an existing automobile. But yeah, in general, the fuel type of an automobile remains fixed. Okay, it is not something that you can change. So this is an example of modification, that your class allowed a particular field to be visible to the outside world, but now there is a risk. The risk is that um, the core behavior of the class is that, let us say, the fuel type doesn't change, but that behavior may not stand anymore. Why? Because a user can actually do object dot fuel type and then change it, right? Change it as many time as wanted, as he or she wants. So this is not wrong, right? I mean, I should not have allowed the user to change the fuel type as often as required. um, Maybe I could have just asked the user for the fuel type once at the time of the creation of the object, and then the fuel type remains exactly the same throughout the object's lifetime. But if I allow the modification of this field, then I'm allowing modification to a core behavior of my class, and it might not be correct in the real world. Does that make sense? Again, it's not always true, right? I mean, maybe in some cases, if I allow modification, the user only modifies it or uses it in the correct fashion. But there is a risk, right? I mean, there is a risk that uh, the core behavior of the class might be changed or lost. That is the idea. Okay, does that make sense?
Okay, sir.
Okay. Any more queries? Okay. So I think this was the second lecture for the. Yeah, we won't have any more lectures, I guess, right, in this week. So all the best for the midsem. I'll keep the midsem to be a short one. I'm planning to only have 15 questions, 15 um, objective type questions, and some 20-25 minutes, 20 minutes maybe, because we haven't covered really much till now. So maybe just a 15 question midsem. And as I said, before midsem, one day before midsem, we'll have a joint combined extra class. And if you have any queries, of course I'll be available on email. My frequency of replying has certainly gone down, but I'm still available on email. So if you have doubts, you can always ask. And otherwise, on 19th also you can ask your doubts. Okay, any more queries, or shall we break? Okay, guys, thank you. Bye.
Thank you, sir.